Hi everyone, it's me, Carolyn, and in this video we are going to be starting chapter 11 of our textbook. And in this chapter we're going to be comparing two different groups, so looking at two proportions or two groups of people. And I'm going to be using a lot more technology in this chapter to do most of the work. I know we did tables in chapter 10. I will do tables in this first section, but when it comes to the next couple sections, I will be using technology exclusively just to save on some of the time. I will be giving you the formulas, so if you really do want to do them by hand, by all means do so. I will also be putting a question out on our Blackboard site to see if you guys want a video on how to do some of this in Excel, because we can do it in Excel. It just requires us to use an add-in. I will again put that in an announcement, so look for that. But I'm going to now share my screen so we can get into chapter 11. Whoops. And in chapter 11, we're going to be, first of all, starting with 11.1. But in 11, we're talking about the inferences between two population proportions or parameters. And in this first section, we're just going to look at two proportions. So the first thing is we do need some definitions about independent versus dependent sampling. So a sampling method is considered to be independent when you have individuals in these two groups, and one set does not dictate who the other set is. So there's no relationship between these two different pieces. A sampling method is dependent if the set that happens here dictates exactly who is going to be in this second set. A lot of times we consider those to be match pairs because we'll see some of those examples when we do 11.2. All right, but in this section, just some things to kind of keep in mind. These are not new pieces of information. They're just extending what we've already kind of done. So the first thing when we're talking about these two proportions, we want to make sure that they are independent from one another. And we do use simple random sampling so that everything is done well. We also want to make sure that our NP 1 minus P for both sets, so this would be like group number 1 and group number 2, are bigger than 10 so that the normal curve can happen. Also that our sample sizes are not too large to make sure that our individuals are independent from one another. Excuse me. There is a formula, so if we wanted to find that 99% confidence interval for the difference between the two, it looks something like this. Notice we have P hat 1 and P hat 2. So this is like for group 1 and for group 2. We still are using our Z because it is a normal. For alpha over 2, again, we take that alpha and split it into the two tails because we're looking for those two pieces. And then we have this ugly looking square root thing. And this is one of the reasons why I use technology a lot, is because our formulas do get a little bit uglier and it's so easy to make a computational mistake. So I will be relying a lot on the calculator or the software to help me out, and also to avoid all those mistakes. But we do have our P hat 1 times 1 minus P hat 1 all over the sample size for group 1. And adding to that the similar fraction, noticing that both of those two pieces are added and are then taking the square root of that. So that is similar to the confidence interval that we saw for a single, but quite a bit more complicated because we do add these extra pieces. All right. The other thing we're going to do in this section is some hypotheses testing. So again, to kind of remind us what the hypotheses tests look like. The 5 steps, we are going to write our hypotheses, and depending on how you like to write them, our null hypothesis is going to be that your P1 is equal to P2. Most of the time, as this is the one we're going to use, you can have another constant in there, but for the most part, when we're introducing these topics, they're just going to be equal. Or if you slid this guy to the other side doing a little algebra, you could have had P1 minus P2 equal to 0. So looking at the difference being 0. The alternative, of course, can be one of the three pieces, the less than, the greater than, or the not equal to, saying that this guy is smaller, this guy is bigger, or they're just different. Notice we don't have a single value in here. We're comparing one group to another. The second step, as it always has been, is to find that alpha. Alpha is, for us, will be given in the problem. In the real world, statisticians who are performing these experiments, setting all these experiments up, will set that confidence level or significance level. Our test statistic, again, really kind of ugly. So it is a Z. We have P hat 1 minus P hat 2. Those are our samples, those sample proportions, minus the 0. This 0 comes from this piece right here. Now, if we were thinking that men are faster by 2 minutes, that 0 would be a 2. So, but for us, we're going to just be testing equals versus not equals, equals versus less than or greater than. So we're not going to be testing to see if they are 5 feet taller, 7 inches shorter, 3 seconds faster. We're going to be just saying they're faster, they're slower, they're taller. All right. The denominator looks a little bit ugly, but we do create what we call a P hat, which is called our pooled approximate. So this is kind of like a pooled proportion. And that's the piece that shows up in our bottom here. So it's a P hat, 1 minus P hat, and then we have this other square root of 1 over N1, sample size of the first one, sample size of the second. So this P hat, this pooled P hat, these are the number of successes in each group over the total number of people. So it's kind of like a pooled, who was agreeing with this or not agreeing. Remember, proportion, we have 2 outcomes. So yes, these are kind of like binomials, but we think of them in terms of proportions, the number of people that thought this way versus another way. Step 4 is to do one of the 2 pieces. We are either going to find the critical values or our p-value. I will do both in here. And then we decide to reject or not reject, and then we write our conclusion. So that is our 5 steps for those hypotheses. Biggest changes, of course, in our hypotheses testing is somewhat what our hypotheses are going to look like, and then of course that wonderful ugly looking test statistic. So we're going to do a single example, which is going to take us a little while because I am going to do this one using the table. I will also do this using technology and so on. And we're going to walk through it a little bit quickly when it comes to some of the formulas, but we'll see how it goes. So here we have, researchers are wondering if there's a difference in the proportion for males and females regarding whether or not they buy name brands, products. They ask simple random samples. So there we go. We have simple random samples of both men and women and find the following. Among 1,104 men, 343 of those bought name brand. Here's the number of women they surveyed. 295 bought name brands. We're supposed to use alpha 0.05 to see if there is a difference between the men and the women. So I'm doing a hypothesis test. I will also do the confidence interval to kind of, since it's going to be a difference, so that's a not equal, that 2 tail to kind of verify it as well. Okay, so I'm going to write my hypotheses. So my 5 steps, I write mine instead of just 1s and 2s. I like to use subscripts that make sense for the problem. So like here, we're talking males versus females. So instead of 1 and 2, I'll have M and F. And we are doing, they're equal versus different. So that would be a not equal. Okay, so there's our step 1. Our step 2 is to find that alpha, and our alpha is that 0.05. Step 3 is our test statistic, but before I do jump into my test statistic, I do want to verify things. Obviously, these are not such large samples that we're going to be more than 5% of our populations for either men or women who do some shopping. But I do want to look at that NP1, 1 minus P1, and I do want to look at NPN2 and 1 minus P2. So for both my men and my women. So in terms of my men, we had 1104. And we have that 343 out of 1104 minus 343. And I'm going to get that value just to make sure that they are 10, more than 10. This is something we should do. Give me a few minutes here on my calculator. So I'm doing some math here. I have 236.4. Obviously, that is bigger than 10. For my women, we have 295 out of the 1172. Again, I'm going to do some calculating here. So taking that 295 divided by the 1172. I'm going to multiply that. Minus the 295. And I have 220.9. Again, that is bigger than 10. So we are okay to go and use our test statistic. So step 3 is to find that test statistic. So our Z is going to be, I'm writing the formulas here, that P hat M minus the P hat females minus the difference that I'm assuming, which is 0, all over this square root P hat 1 minus P hat, which I have to figure out. 1 over N for my males plus 1 over N for my females. Okay. My P hat M, that's that 343 over 1104. Yes, I can turn these into decimals if I want to. Leaving them as fractions will make it a lot more accurate. So there's my females minus 0. I'm not going to put that in here. For my P, I'm going to do the work down here. So I'm going to calculate P hat right here. That's my 343 added to my 295 out of my 1104 plus that 1172. So adding those together, I have 638 over the 2276. So that's going to go in here. We've gone so long here. And then we have a little square root here of 1 over 1104 over 1172. All right, so now very carefully, I'm going to do this on my calculator. Okay, if you do turn this into decimals, carry a few decimals with you. And I might do that just to make it a little bit easier. So I'm going to take that 343 divided by my 1104. That gives me a decimal point 31069. Just going to 5 digits. The more digits you carry, the more accurate you're going to be. The nice thing is when we do use software, they will use the fractions. So we don't have to worry about all of that. Here's my 2803. And then if I do 1 minus that, I have 0.7196. Those two values in there. Okay, so now grunting this all out, I'm going to do the subtraction first. 0.31069 minus the 0.251171. I'm going to get that value. So I do this subtraction, I hit my equal button. Now I need to make sure to divide by all of this. So I have to be a little bit careful when I'm doing this. So I'm going to divide by, and I'm going to put a big parenthesis at the beginning so that I get all of this down. So now in here, I'm going to have that square root of these two things being multiplied together. 0, 2. Times 0.71968, close that. And then my square root. And in here, I'm going to do little bitty parentheses as well. And when I do all that, I get 3.1309, but this is a Z value. So remembering, we usually go to 2 decimals because that's what our table has. So there is our critical value of 3.13. Our test value, sorry, test statistic, test value. Test statistic. Step 4 is where we find either our critical values or that p-value. So I'm going to do my 2 pieces. And I'll also do the critical value. Or remembering the critical value is associated with our alpha. Since we are doing not equals, we're going in 2 directions. So we are going to take that alpha, which is 0.05, and we split it into 2 pieces. So here's 0.025 and 0.025. So if we were using our Z table, we'd be looking for 0.025 or 0.975. If I look under this one, find this guy, find 0.975, 975 inside, there it is. And that is 1.96. So this is my critical value here, 1.96. And it is symmetric about 0. So this is a negative 1.96. If I'm finding the p-value, that's where we're going to think when we're looking up, here's that 3.13. We're finding the p-value. We're going to have to times it by 2 because we're going to need these 2 pieces. Okay, so I look up 3.13 on the table. Remembering this is a Z, so it's on the outside. So 3.13 is 0.9991. 0.9991, but that's the area from here down. So if I subtract it from 1, that gives me 0.0009. That's the area in this piece. Being symmetric, we're going to multiply by 2. There's our p-value. If this was a single tail, one direction, we don't need to multiply by that 2 because we put all of the eggs, so to speak, in one basket. Here we're splitting it up into 2 baskets. So we kind of have to look at both tails. All right. Step 5 is to make our decision. And that's where we kind of do a couple of things. If we're looking at critical values, that's where we take our test value and put it into our picture, see where it fits. Here's 1.96. 3 point something is up here. So that is in that shaded region. It's in that critical region. It's in that rejection region. So we will reject. If we look at our p-value and did it this method, this is where we compare the p-value. We want to know, is it smaller than alpha? Our p-value is 0.0018. It is smaller than our alpha, which is 0.05. We would reject. If this was not equal, we do not reject. So we are rejecting our H naught, which means there is enough evidence to show a difference in the proportion of men and women who buy name brand and name brands. There we go. Okay. Doesn't say who buys more. It just says that they're different. Men and women are different when it comes to buying name brands. We could retest and put a greater than or less than symbol. You know, maybe we looked at what our P hats were and it looked like our men were higher. So we could have said, hey, men buy more name brands. And we could have done that test to see how it would have worked out. Would have been slightly different because we would have had different critical values because we wouldn't have had the split going on here. So it could have been different results. I am going to go to Excel, not Excel, but to StatCrunch to show you how you would do this one using StatCrunch. And at that same time when I'm there, I'm going to find my 95% confidence interval for this data. Just to make sure that we can do that. Yes, you could go and put all the pieces into the formulas. Again, be very careful on doing that. But StatCrunch is so fast that we can easily do a lot of that direction. So I'm going to go and do a new share, and we'll look at StatCrunch here. Okay. So I'm going to steal my papers here so that I can see. So again, we're under the stat button. So in StatCrunch, we go under the stat button and we are doing proportion statistics. Now we are no longer doing a 1 sample, we're doing a 2 sample. And since I have the information, we're doing with summary. I don't have the raw data. I will be doing some examples in future sections with data so that you can see how that works. And we'll get all of that from there. So I'm going to do it with summary. Okay, so here I'm going to be typing in all my number of successes and all of that information. So my men, that was my 343 out of my 1104. My women was 295 out of 1172. We are doing a hypothesis test for P1 minus P2. I like to do equal versus not equal, one side equal the other. They move them to both variables on one side, just an algebraic manipulation. I'm going to show the critical values in there. Make sure your significance level matches what the problem gives you. Ours is a 0.05. So I will use that. And then I'm going to hit compute. And there we go. So we're looking, here's our proportion for population 1, population 2. We're looking at the difference versus equal to 0, not equal to 0. You could have changed it to being less than or greater than at that point as well. Here it gives you all those information that you typed in, a good place to double check to make sure you did it correctly. Down here, we do see our Z statistics at 3.13. Notice they give us a lot more digits because they have a lot more information built in. The critical value here is at 1.9599. We had 1.96 because that's as accurate as our table could get. the p-value that technology gives us was 0.0017. We had 0.0018, again, due to the accuracy of the tables, but it does give us everything we needed. All right, I'm going to go back, close this, and I'm going to, again, this time I'm going to get that confidence interval. So I can remind you how to get a confidence interval for 2 samples. So again, 2 samples with summary. Again, we have to type in all of our information, so that 343 out of our 1104, our 295 out of the 1172. This time we're not doing a hypothesis test, we're doing a confidence interval. Kind of wish it would allow me to do both at once, but it does not. And I think that's all I really need is just that confidence interval. I do want a 95% because my alpha was 0.05. So I'm going to do my computing. And I'm going to write this down here. So again, it gives us the counts. Double check to make sure you got the right pieces in there. There's my lower limit. I'm writing these on my sheet here, and my upper limit. Okay, lower limit of 0.022069, close. And upper limit of 0.095895. And I think that's all I needed. Okay, so I'm going to go back to my guided notes or the works that I was doing. And there was that confidence interval. And to see if this verifies, we rejected. Okay, now we were rejecting the difference. So this is looking at the difference. So this is looking at PM minus PS is what it's looking for. And so the difference between them is somewhere, we're 95% confidence that the difference is between these two numbers. But our hypotheses test, we were looking at them being equal, changing that so they're both on one side, PM minus PF equaling 0. So we're going to be looking to see, is 0 in that interval? And since these are both positive, 0 is not in that interval. So again, we would reject. So we can do the confidence intervals to do it to kind of verify that hypothesis testing for us. Hypothesis testing is a little bit more accurate method because it does do a lot more details, and you would come up against a lot more information as you're working through it. So a lot of times it can lead you to that next question. So like in our problem, we were like, well, maybe men were more. And we might not have seen that if we had just jumped right into the information and got the confidence interval. So anyway, that kind of concludes this piece. I am going to stop sharing. It does kind of end us when we're talking about how to deal with 2 proportions. I did only do 1 example, but all of the examples are going to be similar, just a little bit, either splitting the pieces, putting it all in one side. But again, we do the 5 steps, finding our test values, which again, I go to Excel or to StatCrunch, some sort of technology to do most of the work for us so that we don't have to try to mess with those ugly, ugly, ugly looking formulas. Well, I hope you enjoyed this video, and I look forward to seeing you guys again. See you in the next video.